Good morning, Bharat.
Yes, good morning, sir.
Are there any questions or anything in the forum or
No,
in
sir.
the YouTube channel?
All questions are answered, sir, in discussion forum.
All questions are answered in the
Yes.
discussion forum. Oh, thank good. And are there anybody in the YouTube channel?
As of now, no questions, sir.
Okay, so I had to postpone this. I hopefully people saw the postponement
Yes, sir,
because
sir.
I don't see anybody. There is one. There is one. Good. Good morning, Disha. Uh,
Good morning, sir.
Good morning. So we'll just, if you have a question, and we can discuss your question, but I just thought maybe we can wait for a few minutes.
Sure, sir.
Yes, some doubt in, huh? Besides some doubt. Yeah. Okay, Disha, tell me okay, you are asking in lecture 12, may I know whether equation 4 marked with the hierarchy should be considered negative side or not? Because, okay, so let me just open lecture 12. Just give me a minute.
Yes, sir.
Just give me a minute, please.
Sir, I have also attested the screenshot
Yeah,
also
just
for
give
a
me a minute.
reference.
I need to open my lecture because otherwise, I can see your screenshot. Just give me a minute. So this is module what? Module, this must be module 5 or 6, no? 7, 6. Which module is this, Jobin? Do you know? Just a minute. It's example 2. No. Which module? 4, 3 or 4 or what is it? This is the same with
Sir, should I say the time
no.
for it?
Just wait, just give me a minute. Just give me a minute. I'm just trying to find where oh, this
Sir?
is free body diagram. Okay, so
Yes,
this
sir.
is yeah. So I just give me a minute. I'll find out this free body diagram. So free body diagram is can you just find Jochen where is this free body diagram which is I found it. Just give me a minute. So this is week week 5 or 6, right, Disha?
Sir, week wise, I don't know, but the lecture is free body diagram one only. Free body diagram and equation of motion. Yes, sir, it's week 5.
Week 5, right?
Yes.
Good. I have organized my things according to weeks, so slightly easier if I know which week it is. Okay, good. So let's see your question. Just 1 minute. So you want to know. So can you just repeat your question once more?
Yes, sir. Sir, I am skeptical of the equation 4th,
Uh-huh.
which has terms R2 sine 1 2
Yes.
F2x. So,
Plus.
yes, sir. Sir, in that, are we referring to, so since it's rigid body 2, so I've taken F2x going from in the negative x direction to cancel out the rigid body 1 F2x,
Okay.
which is positive x. So, shouldn't it be negative of R2 sine 1 to F2x?
See, if you go back to 2 slides before that, okay? So this is the slide when we are discussing free body diagram of rigid body 1.
Yes.
So if you see that slide, F2x is pointing along the negative x-axis. That is in that way.
Sir, then if we are considering
So 1
free,
minute. So
yes,
you have seen that, no?
yes, sir.
So this is for rigid body 1. So this is the first link. Okay. So now for rigid body 2, if you go to slide number where the equation number 4, okay, so now that force will be equal and opposite to the previous one. So
Yes.
F2y, if you open, or maybe I will share. Wait. Simplest is I will share my screens. That is the simplest way. Okay.
Yes, sir.
Hello.
Yes, sir.
Okay, just let me just share my screen. That is the simplest way. So can you see my screen?
Yes, sir, it's visible.
Okay. So what are we doing? So what we are doing is we are trying to, I'll just go a little bit. So this is example 2. This is the problem that we are discussing.
Yes.
Okay. So what we have here is 2 rigid bodies connected one after another. And there are these mass, R1, I1, L1, all those parameters are there. Okay. So if you look at the free body diagram of the first link, so then there is a tau 1. Can you see my cursor?
Yes, sir, it's visible.
So tau 1 is this way, weight is this way, and I have assumed in this drawing that the F2x is to the left and F2y is at the towards the minus y direction. Okay.
Yes.
Okay, so this is as far as the rigid body 1 is concerned. And then if you take the rigid body 1, we have this equation m about the origin OA is tau 1 minus tau 2. Tau 2 is in the opposite direction minus, just 1 minute. So tau 1 and tau 2 is in this direction minus mg. So these are the moment equation. Basically, you can see easily it will be some are clockwise and some are anti-clockwise. Okay, so m1g r1c1 is clockwise, so that is with a minus sign. F2y and F2x is anti-clockwise, that is positive. So this is as far as the rigid body 1 is concerned. Now, if you look at the rigid body 2, which is the next slide, okay, so in the case of the rigid body 2, this drawing here shows that F2x is to the right and F2y is to the top. Okay, and that is because of Newton's third law, equal and opposite reaction at the joint. Is that clear?
Yes, sir.
Okay, so this is F2x and so now you can see, go back to this equation. So now you can see what happens is this will be plus R2 S1 to F2x and R2 C1 to F2y. So this is correct. Okay, because again, clockwise and anti-clockwise, we need to make sure that we are doing it in the right way.
Sir, my doubt was if we are considering G downwards as negative,
Yes.
then in the moment equation, shouldn't we consider the direction of gravity also?
Yeah. So if you see the slide, M to G is downwards, no?
Yes.
So there is an F2x, there is an F2y, and then there is a M2G, which is acting at the center of
So,
gravity of the second link. So,
so F2y equations, so both of the equations for link 1 and link 2 have opposite signs. I got it, sir,
only
but
for F2.
F2y. But regarding F2x, again, both of them are equal and opposite for link 1 and link
Yes.
2. So, for moment equation for link 1, the sign for F2x is positive. So, it's positive F2x L1 S1. And again, for link 2, moment equation, it has positive F2x R2 sine theta 2.
So
Shouldn't it be negative?
no, listen. So the thing is, a moment equation assumes counterclockwise positive, clockwise negative. Forces are positive if it is along the x direction and if it is along the positive x and positive y direction. If it is in the negative x and negative y direction, then they are negative sign. That much is clear, right? So
Yes.
if you look at the moment equation for the first one, you can see my slide. You can see the moment about OA. So one is tau 1, it is counterclockwise as it is shown here. Tau 2 is clockwise, so that is minus sign. Then M1G R1 C1. So R1 C1 is this perpendicular distance and it is also clockwise, so it is negative. Similarly, F2y is also F2y L1 C1 is also negative because it is clockwise, whereas F2x is counterclockwise. So that is why there's a positive sign. So this is
Sir, then following this convention for link 2.
Yes, I will come to link 2. Just give me a minute.
Yes, sir.
So this is clear, no? So
Yes, sir.
if the force is along plus x positive, plus y positive, and negative x and so on. Moment counterclockwise positive, clockwise negative. Okay, so now for the second link, one important thing to realize is we are going to take moment about which point. So you can only take moment about the CG. Okay. the moment is either about a fixed point or about the CG. Otherwise, this Euler's equation is not valid. I cannot take moment about the where F2x and F2y are together, are acting at the point. Okay, so I can't take moment about this point. I have to take about the CG. So now if you about the CG, you can see F2x is positive because it is counterclockwise. F2y is negative because it is clockwise. And G doesn't show up because the moment about the center doesn't show up. Is that clear?
Yes, sir.
So that is why in this equation for rigid body 2, there is one tau 2. So tau 2 is again equal and opposite. So previously in this other free body diagram, okay, where is the other free body diagram? Here. So the other free body diagram, tau 2 is clockwise as drawn here. Okay. And
Yes.
for the second link, tau 2 is counterclockwise because it's equal and opposite. Okay. So
Yes.
hence, when you do this moment equation, you will see tau 2 is positive, and then R2 into F2x. So this is the distance is R2. So F2x is also counterclockwise, which is why it is positive, and so on. Okay. So all these terms are correct.
Sir, F2y is negative
Which
since
one?
it's for link 2, F2y is clockwise.
F2y is clockwise. Just one minute, but I am taking moment about the CG. So F2x is clockwise. Oh, you are saying in the second term it should be negative. Is that what you are
Yes,
saying?
sir. Yes, sir.
Okay, can you send me one email? Because I will go back to my original derivation. Maybe this is because of the way this thing is drawn. Okay. Maybe because of the way this thing is drawn.
Or, sir, I guess if we are taking it as clockwise, it's negative. And again, we are taking G, we are going in opposite direction of gravity. So
No,
it
no, no, no,
should be
no.
negative
G,
cross
no, no,
negative.
no, 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 no. G doesn't change. In the free body diagram, you are not supposed to change the direction of gravity. Okay. So G, M2G is for the second link. G is always downwards. Okay. So only the contact forces you have to change the direction. So this in the link, no, in the first link is connected to the second link at that point, at that joint. So when you do the free body diagram, only the contact forces are equal and opposite.
Got it.
Okay. It is not the gravity, or if there was so there are no yeah, contact forces only equal and opposite, Newton's third law. Okay, so can you send me one email? You have my email ID, no? I will carefully go through it. I don't know whether I have made a mistake in writing these things. It is possible I have made a mistake. Okay, so I will will derive it everything, and then I will see.
Sir,
So,
in that query forum only, right?
no. I will type you my email ID. That is slightly better. Query forum. Sometimes it's not so easy to access. So please send me one, just let me see, how do I? Oh, I have to stop sharing. Okay, so chat. So you can send me at my ISC address. Okay,
Yes, sir.
where are you from, Isha?
Sir, right now I'm researching in IIT Bombay, under controls.
Okay.
Like, I'm just gone.
Okay. So I've sent my email. This is my email ID. So see, the one of the reason for doing that is I wanted to show that you will get the same equation of motion using Lagrangian formulation. Later on, you will see, as well as
Yes,
using Newton's law, as well as all these propagation formulas. Okay.
yes,
So I will go through it once more. If so, it is possible that I have typed, while writing by hand, I made a mistake. In that case, I will correct it. But the final equations are correct because they have been checked
okay.
using all the three approaches.
Yes, no problem, sir. Sir, and
Yeah,
Sir,
go
there's
ahead.
one more query.
yes, sir.
He has. Yeah, go ahead. One
I have
more.
posted.
What is the other query you have? Yeah, could you explain the highlighted terms below? Generalize when it should be F2Y. Okay.
So, sir,
This is when?
slide lecture 12, page number 21.
Okay, same lecture, huh? Okay. This is no, this is not that lecture. This is which module is this? You can see.
Yes, sir, I found from this one. Lecture 10, 11, 12, 13 PDF.
No, it is not there. That is this course. Here, this is NPTEL. Okay, just 1 minute. Disha, just wait a minute, please.
Yes, sir.
So which module is this? Can you just let me know? It will be faster for me.
Sir, I'm also finding just a second, sir.
Yeah. This is about generalized coordinates, right?
Yes, sir.
So this will still be week 5, but okay. Yeah, I found it. Okay. So let me just share. No, I still haven't found it. Wait. So did you find it, Disha?
No, sir.
Okay, just give me a minute.
Sir, I didn't know if I had to mention
No, it's
the
okay.
lecture also.
It'll just take me a few more minutes. I thought I'd just make it faster. That's all. That is the only thing. There is no issue otherwise. Okay, so again, you are asking whether that Fy2 L1 sine theta it should be positive, negative, or what, right?
No, sir.
Uh,
Sir, actually, my question is for q theta.
uh,
For if we have taken Fy to L1,
yeah,
shouldn't it be cos theta?
okay. Fy2,
Because we have taken del R1 and del R2.
ah,
So considering del R1,
uh-huh.
the y coordinate is L1 cos theta del theta.
Okay. Oh, good question. Ah, just 1 minute. I remember doing all these things carefully. So now, thank you for raising these doubts. But see again, okay, you have anything else? I'm still trying to search the place from where the original equations are given. So,
Sir, I got the lecture number.
tell me.
It's lecture 10, external forces and moments.
Oh,
1 hour 6 minutes.
okay. Okay, good, good, good. I also found it. Thank you. Okay, so
Yes.
let me just share the screen, and then we'll discuss. Okay, so this is the screen, right?
Yes, sir.
Okay, now let's go over it. So your question is this Fy2 L1 sine theta. Yeah, most probably you are right. Okay. So that is certainly
Must be
most
mostly
probably.
cos theta.
Yeah, yes,
Okay.
yes, yes, yes. So see, this this is clearly a mistake. You cannot have both L1 sine theta and again another L1 sine theta. So that is certainly a typo.
And sir, like for link
Because
3,
it has to be one sine and one cos. Okay, can you please
yes.
send me an email? I don't know how to mark it right now. Okay, good. Let me just write
Okay,
it down.
sir.
At least I will correct this in the next. This one. Yeah, that is wrong. So this is example 5. Okay. Example 5, Q theta. M1 fx2 L1 sine theta plus it should be fy2 L1 cos theta. No. Thank you. Okay, good. Tell
Yes,
me.
sir.
Yeah.
Sir, I wanted to ask, like for link 3, if we are writing the equation,
Ah,
for maybe Q means somewhere I don't remember, but
ah,
you had changed the axis for link 3. Like if we are adding phi 1 plus
ah,
phi 2 and theta 1,
ah.
so does that mean we are considering F2 point?
This is the same example, right? Is it example 5 still?
Um, sure, like it was 4-bar mechanism only.
Ah,
But I don't remember exactly where it was.
I see. See, in this 4-bar, I'm still sharing my screen. You can see it,
Yes,
no?
yes, sir.
Okay. So, in this 4-bar mechanism, you have to be a little bit careful about how these angles are given. So theta 1 is this one, but phi 2 is in the, again, everything is anti-clockwise. So it is from this extended line all the way to this. Similarly, phi 3 and phi 1, phi 2, phi 3, they are all anti-clockwise is positive. So I have drawn the angle, so it looks like, it's actually 180 plus theta. So you have to be careful with this. Is that
Sir,
the question?
mostly it was this example only.
Uh,
Um, uh, so I exactly don't remember. Yeah.
you can send me email if you still have doubts. So these equations are correct. Okay, so P1, this point P1 is L1 cos theta 1 plus L1 sin theta 1, 0.
Yes, yes,
So the other P2, okay, so P2 is this point is L1 C1. So now is this cos theta 1 plus theta 2, but you have to be careful that this, so theta 1 plus actually phi 2, okay, as it is mentioned here. Okay, similarly, 1 plus 2 plus 3. And if you do the angles correctly, always counterclockwise positive from the extended line along this line. So you can see this line is from here all the way to here. It would have been easier to go directly from here to here, but then it is
hmm.
clockwise.
Okay.
Hmm,
Yes,
So if
sir.
you do it, so this is relative angle. So relative angles are always from the previous link to the next link, from the previous rigid body to the next rigid body, and always counterclockwise positive.
Yes, sir.
Hmm. So this is why this, although this angle looks funny, but this is why it is, all these equations are correct.
Yes, sir. Yes.
Okay, and then once you accept that these equations are correct, then angular velocities are this, and then you can also find out what are the generalized coordinates.
Yes. Sir, I had one question I asked it in the forum also for planar 3D link.
Okay,
It's on week 3.
okay. Week 3. Let me just open it. Okay, week 3.
Lecture 8, position, velocity, and acceleration.
Yes, this one. Just one moment. It's taking a little bit of time. Okay. So here is, I'll again share it. So this is for, you are saying this is for, so is this the one? Oh, wait. How do I share it now? So this is the one, right?
Yes, sir.
Okay, tell me, what is the question?
Sir, in the 16th slide,
16th slide. Okay,
yes,
next one.
after this next
Uh,
one. Sir, why are we considering y coordinate for linear velocity for link 2, I equals to 2?
mhm. Why are we considering which term you don't, it is
Sir, 2, 2
I
for
know, 2v2, this is this one, right?
yes. So if the
Ah,
rotational matrix is, we are considering that Z is the rotation. So
yes,
we have taken third 3 cross the last term
yes.
as 1,
Ah,
and but why it's 0 L1 theta 1 dot and 0?
okay.
Shouldn't it be 0
No, no,
0
no, no, no,
L1?
no. So go back to the previous step. Okay, so if you go back to the algorithm, okay, so this is the algorithm, right?
Yes.
Okay, so not acceleration, we want to look at velocity. So if you look at this velocity, so this velocity term, if it is rotary joint, then the velocity of the origin is the previous origin plus omega cross r.
Sir, it's with respect to OI. And
Yes.
yes,
Ah,
sir, now if we consider, okay, sir, I considered the prismatic joint.
yeah.
Therefore, I was getting 1 omega
Hmm.
1.
Yeah.
So, sir, if it's a prismatic joint, then
Hmm.
we should take 0 0 and the
Yes.
last one.
Yes. Yes.
Uh, sir, so
So
for
this
rotate,
L1 theta 1, so it's like as if with reference to second coordinate system, what is the velocity of this? So don't worry about this rotation matrix. So as far as you are concerned, the velocity of the link 2 with respect to link 2 is perpendicular to link 2, right?
yes.
So that's why there is only a y component.
Or sir, should I think like y2
Hmm.
is perpendicular to the link.
Yes, of course. X is always along the link, Y is always perpendicular to the link.
Okay.
So you can see
Yes.
Y1 and X1. X1 is along the link, Y1 is perpendicular to the link.
Yes.
Similarly, Y2 and X2.
So the rotation matrix will be for considering z-axis since the rotation axis is z.
Yes. So that's why
And
it is C2, S2, 0, and then the 0, 0, 1.
okay.
Because it's rotation about the z-axis. So rotation about the z-axis means the z component, last row and third column is 0, 0, 1.
Yes, sir. And last doubt I had was in lecture 5.
Mhm.
So it was just a notation thing.
Okay. Which one
So
is
I
this?
shared it in the doubt forum also.
Okay, can so you are a BTech student or a master student?
No, sir, I have completed BTech.
And you are working as this JRF or something like
Yes,
that, huh?
JRF.
Okay. Okay, so what is the doubt? Just 1 minute.
Yes.
So I can't see both of them at the same time. So that is why there is a person, the TA is sitting in front of me. He is trying to recover your doubt. If you have the doubt, if you want to say it, you can say it directly.
Sir, I have shared both of the slides together.
Huh?
Like for lecture 5,
Okay.
I'd taken 2 slides and then compiled it in the mail because I was referring both of
Okay,
them and I have
in
doubt.
lecture 5, right?
Yes.
Yes.
I have shared.
No share.
Yes.
Okay. Well, point B, there is a one term after pre-multiplying with this, which means that the velocity of the origin should the velocity. Okay, just 1 minute.
Sir, here for the linear velocity, I got it, but for the acceleration, where it's written acceleration point of P in coordinate B. So, shouldn't it be P in A coordinate because we are multiplying the rotational matrix.
I'm just coming to that. Just give me a minute. So this is slide number 14, right?
Sir, I cannot see the screen.
Oh, you can see the screen. Can you see the screen now?
Yes, sir.
Okay. So let's start from here. So this is clear. This slide 13, both velocity. So first part is velocity, and then this is the acceleration.
Yes, sir.
Okay. So which one? So then this is, if it is prismatic, then it is some d dot will come. And then if it is prismatic, di double dot will come also. So which part? So what is your question now?
Sir, my question was in lecture 5.
Yeah, this is lecture 5. Oh, lecture 5. Not this question, not this one,
No,
right?
sir.
Okay.
Sir, motion of rigid body and particles. Just a question about notation.
Hmm. So your problem is what is it in this slide,
So
Disha?
motion of rigid body and particles is the lecture name.
Motion of rigid body particles. So just give me a minute.
Yes, sir.
This one.
Under week 2.
Just give me a minute. Okay. So motion of rigid body and particles, I got it now. So just give me a minute. Okay, so this slides, right? Motion of rigid body and
Yes,
particle. Okay, so now which I will go through the slides, you stop me, okay?
yes, sir.
So this is the second slide, third slide. This is the second slide. Then this is the next one. Then this is this one. Then this one. Is this the one?
No, sir.
Okay.
Yes,
This one, huh?
yes, sir.
Okay, good. Tell me.
Sir, if we are multiplying the rotational matrix,
Uh,
then we are changing the coordinates. So,
yes.
acceleration of point P
Uh-huh.
should be in a coordinate system, right? For the
Every,
last point.
everything is in A coordinates. So are you talking about this term here? This term here, A, B, R, B, A, P?
Yes, sir.
So see what this BAP means is, so this is the so one good way of thinking about this term is, suppose this point P is an ant, okay?
Yes,
It's a particle like an ant which is sitting on this rigid body and it is moving. It is located with respect to the rigid body with this position vector BP, and it has a velocity and an acceleration. It is as if, so you can think of the classic example of a record player, and there is an ant sitting there and the ant is moving on the record player, okay, with some velocity and acceleration. So this point BAP is the velocity of the ant in the B coordinate system. And we pre-multiplied by ABR because everything must be written in the A coordinate system. So these are all vectors. Okay, first, second, third, fourth, all of them are vectors. and you can only add vectors in the same coordinate system. So the last term is basically pre-multiplying by a rotation matrix so as to convert the acceleration of this particle in the B coordinate system back to the A coordinate system. Am I
Okay.
clear?
Yes,
Am I
so
clear?
B is the disk in which
Ah.
it's rotating,
B,
and
the
A,
rigid body B is like a disk which is rotating, and P is like an ant which is also rotating with the disk and also moving. It is going up, back and forth in some direction.
hmm. Sure, so that the last term which is
Ah,
defined
ah.
in the end of the slide, it should be mostly acceleration of point P in A, or are we referring to just BAP?
No. This after pre-multiplying by the rotation matrix, it is the acceleration of the P in the A coordinate system.
Okay. Sure, so
Everything on the right hand side must be in the A coordinate system.
okay, sure, like I was asking that you have defined the rotational matrix multiplied by acceleration
Ah,
at the end.
ah.
It's written in B, so I was confused.
No. So look at this term BAP, which is after the rotation matrix. So that is the acceleration of this particle in the B coordinate system. Just like the term before that, so there is a term BVP. Can you see that?
Yes, so
So
P in point P,
the
velocity in B coordinate system.
yes.
Sir, so that last term that you
Hmm,
have defined,
hmm.
sir, at the bottom of the slide in red
Yes.
text.
Ah.
So in that we have written P
No,
in
no,
B.
no. So, oh, okay. You are confused because so BAP is the acceleration of point in B, not
Okay,
okay.
okay.
Good. Yeah. So the text is wrong.
Yes,
So
sir, I
so
was therefore confused.
okay, very good. Thank you very much. So this text is wrong. So the acceleration of point BP in A is BAP, not pre-multiplied by. So I shouldn't have written the rotation matrix,
Yes,
or
okay.
it should be in A.
A coordinate,
Yes,
yes.
yes, correct, absolutely. Thank you. Hmm.
Sure, so are we having any other doubt clearing sessions before exams?
Normally there are three, no?
Okay.
So normally there are three. So uh, I think we need to have one more before the exam.
Okay, sir.
Hmm.
And sir, about all these derivations and that won't be asked in the exams.
No. The final exam is always um, uh, MCQ.
Okay, sir.
So who are you working with
Sir,
in IIT
under
Bombay?
Professor Vivek Natarajan, under Department of Center of Systems and
Uh,
Controls.
Department of?
Center for Systems and Controls.
Oh, okay.
So, like in my BTech, I didn't have any controls course, so I thought to take it before applying for masters.
Okay, good idea. Hmm. Good. You can send me email whenever you have any doubt. See the forum, once in a while I look at it, but if you send me email, you'll get a quicker response.
Okay, sir.
And we can chat like this. We can set up a Google Meet if you want. So you don't have to wait for So you can collect a few questions and then you can tell me and I will come online and we can discuss.
No, sir, I was actually very much confused of few
Oh,
of these
Ah.
queries.
okay, no problem.
Yes.
There is nothing wrong in asking for clarity or clearing doubt. I mean, that is the whole purpose of this.
Yes, sir.
So where do you want to do masters?
So like I've applied to few of the colleges in Germany because
Hmm.
I'm particularly interested into robotics and controls side.
So is
And
it, have you got good response?
so like for I've just applied to 3 colleges right now because many of them are applications are still not yet open.
Mhm. Okay.
And so not much response, but my according to my transcripts and everything, I'm qualified.
Okay.
So I'll see what's there.
Mm. Okay, good.
Yes.
Do you have any other questions?
No, sir, not yet.
Okay, good,
Thank you
good.
so much, sir.
No problem. Absolutely no problem.
So should I leave?
Yeah, if you are done, we can leave. I mean, it's not a, yeah.
Okay, sir. Thank you so much, sir.
Thank you.
Good day,
Thank
sir.
you. Good. Bye.
Bye, sir.
Bharat, are there any other questions in either the forum or in YouTube?
No, sir, I'll check.
No, sir.
Okay. So we'll wait for 2 minutes because we should be there till 2:30, 11:30, no?
Yeah, yes, sir.
Okay, so we'll wait for 2 minutes and then we can close.
Okay, sir.
Anyway, this is one, I think she was very asking, she's found out at least 2 mistakes in the slides, which is very good. Typing mistakes.
Yes, so there is a query
Ah,
regarding week 8 assignment
ah.
from Rima Ghosh.
Just 1 minute, Bharat. There is a query from one student. For question 7, week assignment, multiple options. There can be multiple. Okay, let me just open. Ah, ah. Question 7.
Yes.
See this question for Rima. I don't know how should I type. Are you there, Rima?
No, sir.
Okay, so for a linear system, there is only one equilibrium point. The example of a pendulum, okay, is not valid for a linear system is not for a linear system. Pendulum is nonlinear. And hence there are two equilibrium points. Okay. So you can listen to the answer, or you can see the slides, to see the chart which I have typed. So the whatever the given answer is correct.
I have shared in QA form.
Okay. Okay, I think Bharat, we can close, right?
Yes, sir, we can close.
Because already 11:33, there are no other questions in chat box or forum or YouTube. So,
We can wind up, sir.
okay, good. Thank you very much, everyone. So
Thank you,
we
sir.
can close. Thank you.